This is video 3 of 4 for the 10-2 notes. Now we're going to move into the area of a kite and a rhombus. Area formula for both of these figures is exactly the same. Again, if you want an explanation on where these formulas came from, they were developed from two triangle formulas getting pushed together to build one formula. So let's break down the formula first. First variable you see here is D1. And keep in mind you can use any version of this formula. I have 3 of them. I usually like to use this first one. But D1 is a diagonal. And the diagonal starts at a point on the rhombus or the kite, and it travels through the figure to a non-consecutive point, which means, let's say I take a look at example B. If I started here at E and traveled all the way down to G, that would be considered a diagonal. In part C, I could start right here at this point, travel all the way through the figure, and that would be considered D1, a diagonal. Or take note in part A, we'll call number 8, where it's written all in blue from one side all the way to the other side of the rhombus, would be one diagonal. The second variable is the other diagonal, D2, which would be, if I'm on part B, I start next to point D, travel all the way through the rhombus to the other side of the figure, and that would be a diagonal. And then with the kite in part C, start at one point, travel all the way through the figure to the other. And then lastly in part A, the 12 that's written in red would be the second diagonal. So really we're taking the product of the diagonals and then taking half of that value. So let's find the area of our rhombus. Just things to recall about a rhombus in part A. Rhombus by definition is a quadrilateral with 4 sides congruent. There's lots of properties that are true about a rhombus. I posted a couple of videos in the enrichment section, but some of the main ones are rhombus diagonals always meet at a 90-degree angle. Notice that's already denoted in part B, and kite diagonals always meet at 90-degree angles. So important facts for us to use. And then last one, a diagonal always bisects another diagonal inside of a rhombus. So notice how the smaller pieces on each diagonal I'm labeling are congruent. Happens with a rhombus. The smaller portions of a diagonal are always congruent to each other because the diagonals bisect each other. Not always true for a kite, but we'll get to that one in a moment. So finding the area of the first rhombus, we'd have 0.5 times the first diagonal, which is 8, times the second diagonal, which is 12. And again, I think we can handle some mental math here. We have half of 8, which is 4. 4 times 12 will give us a grand total of 48. We don't have any units on the 8 or the 12, so we're going to call this area 48 units squared. Next rhombus. So we have right here, we have one distance, and notice how this distance is on the inside, this value of 4. And notice how before I put in the coloring, it was a little different than part A. See how the whole diagonal was labeled 8 in part A and it was in blue? Well, this isn't saying the whole diagonal is 8. This is saying just this distance right here is 4. So if we wanted to create the whole diagonal, that distance is repeated over here from R to F. So this distance would be 4, making the total diagonal 8. Same with this value of 3. From the corner to the center is 3. So the whole diagonal would be 3 plus 3, which would be 6. Very easy mental math for us. Half of 8 is 4. 4 times 6 is 24 units squared. It's another good time to mention too, similar to the last unit when we're calculating areas, we want all our areas to be exact. So notice how a lot of these numbers we're using are whole numbers. If you had decimals to 2, 3, 4 places, doesn't matter. Write your results as exact as possible. Okay, lastly, finding the area of the kite. So we have one diagonal, which includes 4 meters and 9 more meters. So 4 plus 9 would give us 13 meters. The other diagonal is 3 meters plus 3 meters, which gives us 6 meters. We want half of that. Half of 6 is 3. And 3 times 13, 3 times 10 is 30. 3 times 3 is 9. Grand total of 39 meters squared. So we want the product of the diagonals, multiply the values of the diagonals, and then cut that value in half, and that is how you calculate the area of a kite or a rhombus.